say. Sometimes we just mix it up with sports and marketing. Now we're going to talk a little medical. All right, it's not going to be technical because there's a sports and a business angle to this. And if you listen carefully and you've had an injury of any kind, especially with tendons and all those kind of things that lawyers don't understand, you better listen to this, because this is not only going to help your quarterback who has torn an Achilles, but every human being down the road. Jeff Conroy, CEO, founder, Embody. Tell me a little bit about your background, obviously how does a former president of a tissue bank begin to create a business that may revolutionize how people heal?
Yeah, no, great question. You know, my experience in learning the sports medicine business was in how donor tendons and products that are manufactured from cadavers end up used in surgical procedures and put into our bodies. And I really looked at a lot of that experience as saying there had to be a better way to engineer purpose-built products that would be more high performance, and as opposed to if you have an ACL replacement and you have to have the tendon of a 70-year-old donor who probably died from cardiovascular or diabetes diseases, those aren't exactly high-performance parts to put into an athlete. And so one of the things that struck me in looking at ways to approach building a company to focus on those things was really looking at some of the most high-performance athletes in the world, which are elite warfighters. And when you've got Navy SEALs, Green Berets, all kinds of technical special operations forces, and we've got a lot of parallels, certainly not parallels in terms of the danger or the consequences, but in terms of athletes who are driven and who constantly are faced with injuries, debilitating injuries, which could be career-ending. There's a lot of parallels in accelerating recovery. So that's kind of a long answer to, I was looking for ways to find technology that we could leverage that would really just be cutting edge, advanced. How do we harness the body's own healing properties and potential, and how do we avoid using cadaver parts and in surgical repair, and how do we move to a future where bioengineering, biomaterials, advanced manufacturing drive these opportunities.
So before we get to the business part, now's the hard part, because I'm going to ask you to explain it in a way that humans, can understand. This is not your dad's replacement surgery. The idea of producing scaffolds for Achilles repair as well as other opportunities in the body is something unique and is a very important part of your differentiation. So talk a little bit about that.
Yeah, no, exactly. So the whole idea here is that we've chosen, and in terms of building blocks of products, we've tried to use proteins and collagen specifically, and collagen that's clinical grade and used in medical devices, to be able to engineer these scaffolds, which are really cell-friendly environments. So if you've torn an Achilles tendon and you're going to have a surgical repair to reinforce and restore your biomechanical strength or just your function, our collagen scaffolds would be wrapped around that surgical repair, and they actually provide a pro-healing environment where your own cells in the body migrate into those scaffolds, and they attach and they infiltrate and they stimulate your own new tissue to grow. So new tendon-like tissue grows over the surgical repair. And the whole idea is just, if we can use regenerative medicine to accelerate new tissue growing at the site of a surgical repair, we've got a real chance at reducing rehab and putting athletes of all kinds in a position to recover pre-injury performance, come back faster, come back with the same skills you had previously.
So just quickly, so people can visualize it, this is a medical term, I guess, in a way, but think of a scaffold as like a little ladder, right? And the stuff grows on that ladder and heals you faster. Is that right, or am I totally wrong?
Absolutely. I mean, the best way to describe it is your Achilles tendon. Your Achilles looks like a bundle of dry spaghetti. All high performance fibers all running in the same direction. So we build a scaffold out of microfibers that are aligned in the same direction, and we wrap it around in that surgical repair. And it really is when the native cells in your body find that scaffold, they're in a familiar environment. So they don't turn into scar tissue. They're stimulated to stretch and turn into new tendon-like tissue.
Ladies and gentlemen, I bet you didn't think on a sports business show you're going to hear the analogy between an Achilles tendon and some dry spaghetti, but here we are. So listen, the other piece of this is from a business perspective for professional and college and high-performance athletes. We'll get to you and me later. But healing process, I know you are very circumspect at over-promising and under-delivering, so you can't get specific on this, but say a quarterback tears his Achilles, and it's 15, 16, 17 months before he's even back. What's the prognosis under this scheme?
Well, great question, and these are things that we will prove out in human trials after we get to market. And so I have to be careful about claims. I think one of the goals that we're really focused on is really reducing the recovery time, and one of the things you need to do is get back to natural movement after that repair. So instead of, what we hope to prove is that you can greatly reduce the boot time, the isolation time that you have, where that tendon is not moving after surgery. And we hope to say instead of 8 or 12 weeks, maybe we can get the patient out of the boot in 6 weeks. That's one objective. And the second objective is that you've got, by stimulating these new cells to grow and new tissue, you're recellularizing and reanimating that surgical repair. And we're gonna do trials in athletes at a couple of large medical centers here in the Southeast, and we'll be proving that out. But I mean, clearly, it's hard in an FDA regulated environment to make too many claims about what we can do for quarterbacks. But, we really believe, and one of the reasons that the Department of Defense and DARPA in particular funded us was that there's got to be a better solution here than the scarring that occurs following some of the current repairs that are done. And what we can say about a quarterback is, look, putting this kind of a product into that repair site is going to minimize the scarring. If we minimize the scarring, we're going to accelerate the rehab. We're going to push them to get back and give them the confidence to get back as soon as possible. I don't know if that answers your question.
Well, answer the question as well as you can under the current business circumstances, which is really important. And from a business show perspective, let's talk about that side of the world. You mentioned DARPA a couple of times. Tell us a little bit about that program and what it is and why it's been so important to your development.
No, fantastic. The Department of Defense has an agency called DARPA, the Defense Advanced Research Projects Agency, and DARPA is the moonshot factory of the DoD, and so the internet was created from DARPA. Drones and robots are created through DARPA funding, and we've spent it's a highly competitive process, and we made a case to these folks that restoring these elite warfighters to service faster and with pre-injury performance levels capable of being recovered was a priority, and they agreed. A special operations warrior, a Navy SEAL or Green Beret are multi-million-dollar assets, and returning them to service following things like soft tissue injuries. Fully a third of the injuries, or some of the most prevalent injuries that special operations forces face, are Achilles, rotator cuff, and ACL. And so DARPA's mandate is to advance the standards across the board in terms of how technology impacts warfighters. And this happens to be one that's focused on health in terms of restoring performance following tendon and ligament injuries. We're funded under a program called Atoms to Products, which is really looking at things at the nanoscale and engineering solutions, and really lots of smart physicists and biologists and biomaterials experts, both in DARPA and on my team, who've had the chance to collaborate. So it's been a fantastic experience.
It's ironic that Navy SEALs and the improvement of their lot helped the next generation of Dan Marinos and Richard Shermans and the other folks that tear their Achilles or any other body parts from the NFL and other sports. Quite fascinating. And just so we know how far you've come, I don't know if you're prepared to tell us how much DARPA has actually funded you guys. It's significant. Can you give us the number, or do you just want to give us a range? I mean, you're free to do it.
Great question. You know, our DARPA program has been funded at $12 million over the last 4 years. We still have another year and a half to go of that funding. We've been very successful in raising some other grant funding, several $1 million through some programs in the state of Virginia. And we're also working with the Army, we're working with the Navy, we're working with some NIH groups, and all kinds of ways to put together non-dilutive funding. And then on the investment funding side, we continue to raise money like any small startup looking to become a growth stage company. We're effectively constantly raising funding, and we just started at the beginning of this year, and it's been going very well.
And so the idea of insurance companies with the pharmacoeconomic studies and teams and leagues on the professional level, I assume they're all supportive of you because less injuries help everybody?
Oh, absolutely. And player health is a priority. I think we, you know, in the YouTube or Instagram or constant media is constantly available. We see too many Achilles injuries or compound fractures on TV, and I think player health and the ability of these players to recover from these injuries, it's a priority of everyone in the chain, from the players to the owners to the leagues and the players associations. And we've seen that. I mean, we've had a chance to meet with some of the folks from the NBA and also some of the folks in the NFL, and player health is a clear priority.
Final question or set of questions that I think everybody wants to know is, assuming successful scaling, when is this technology available for the general public and the weekend warrior? At what extent, and how long will it take?
Yeah, no, absolutely. Our plan is to launch our Achilles product by the end of next year, and towards the end of next year in the fourth quarter. So we will be seeking FDA approval and getting commercial. And what's great about the path that we've had to market is it's available to any sports medicine patient the day that it's available for a Navy SEAL or a quarterback. And so the idea here is we will be commercial next year with this Achilles product. We're working on the same type of product for the rotator cuff in the shoulder. We're also developing one of the first resorbable internal braces, kind of if you have a strain in an ACL and you want to put a high-performance suture through it to reinforce that. We're doing one out of 100% collagen. And then longer term for us, we're looking to build ACLs that are just fully engineered, all made from collagen. We're building some fibers that are as strong as steel in our labs here. And so the future is really, I won't go to a cadaver for an ACL repair, even for a weekend warrior, or I won't have to have a second surgery and take part of your patella tendon or part of your hamstring to rebuild your ACL. And so that's the goal for us longer term, will be in the ACL replacement business.
Quite clearly, all I need to do with my tattered body is to stay one step near your medical marvels. And with Jeff Conroy running the show, it ought to happen. Rick Horrow, speak with you soon. We deviate